All right, so now we're back into programming languages. And our next speaker is Yinben Xiao. Yinben is a researcher with Huawei, and he's doing a very interesting project in which he's trying to program the network via intents. So he's going to tell us a little bit about this project.
Okay, thank you very much. I'm Yinben from IP Research, Huawei IP Research Department. I'm glad to have this chance to introduce our research, NEMO. My language is not so good, so sometimes I need to read my notes. Sorry for that. Okay. I think the program is a very important interface for the open, so this workshop is very important and valuable. But maybe I introduce the programming language a little bit different with today others programming language for the network, because I think the network have a different level and different role. So different role see the network have a different requirement. Maybe they need a different programming target and programming language. So here is I give some different level. Today we talk about P4 frenetic. This P4 is a cheap programming language. It's programming for the network processor inside the behavior, how to parser, how to match, how to encapsulation. It's a cheap inside behavior. Frenetic is a device programming language. It's programming for the device behavior. It can create a new function of a device, a new function in the network. All these two type of programming language is build new function and new mechanism in the network. But we also have another level user. It's an end user and a programmer who only want to use network. He want to integrate network resource and capability into their service, into their application. So this is another type of a user. So today here you all the network experts. So you hope the network is a white box. So you can change the function and the behavior in network. But someone who also like network also be a black box. He can easily use network, easily integrate network in their service. Here is a problem, but does this type of user, do they need a programming language for the network? I think it's yes. The answer is yes, because network is an infrastructure. The user, most of the IT programmer integrate network into their service. So they also want to program with the network behavior and the service. So they use the network as a service programming language. So that is all different. All project is a target to this type user. So next problem is how to programming. There are two types of the programming interface. One is API and another is the language. Here is I give some comparison about these two types. API is a concrete interface for the functional. It's very easy to design and provide because you implement some function. You can easily open this function, the interface to the others. But API are hard to complete. It's exhaustive. So it also API have a lot about implementation detail. So it's always the vendor specific. It's hard to standard, and very important. API is a standalone. One API plus another API is two API, two function. So it cannot be composable. But a language is not based on the function. It's based on abstraction. So it needs a well abstraction. it summarizes the key entity of area. It consists and can be composable, but the language is hard to design and provide. It depends on the abstraction. A good abstraction can provide a good language. So our research is try to find a language, a good abstraction for the network, and design a language. So if the language based on abstraction, so how to abstraction network? There are we found that I have two types of abstraction. One is a bottom up. This bottom up abstraction is what I can do and what I open. It's very straightforward and very easy. So it's more suitable for the functional. Another way is a top-down abstraction, because we mentioned all target user is the programmer who use the network. So we need use customer view to abstract network. What I want is the key for this abstraction. Actually, from the customer view, network become simple because we hide the difference between the solution, between the different implementation technology. We hide the difference between the device. So I summarized the requirement for the network have three types. One is the resource requirement. Another is the behavior requirement for the network. The third is the information requirement, get information requirement. So these three types of the requirement, we also can abstract it. For resource, network become very simple. Network is a node connection and it's the flow over it. Only these three entity of the object in the network. For the behavior, it's a policy control. I want to control the network by a policy, and the get information is a query and a notification. So, top-down abstraction network make network become very simple, and this abstraction get the model is a technical neutral, and we can build application is technical independent. So we now have a.
I mean, this is not a new idea, though.
Yeah, maybe it's very simple, but actually now we don't provide so simple interface to
I mean,
user.
if you go back to the previous slide, I mean, there are already solutions that do exactly what's on the right? Top-down, customer-intent-driven,
Yeah.
policy-driven interfaces.
But actually, we don't have a real this interface. It's this model is very simple, very most network expert can easily understand it, but not real interface provided.
Participatory networking, SIGCOMM 2013, does exactly that.
What?
Participatory networking, PAIN. The idea is exactly that an application, not a user or an application, can dictate what they want out of the network, and there's even a hierarchical model of policies and sharing.
But we don't find the real system support this systematic the interface in the real world.
Maybe find a customer.
Okay, I guess it has to be the real world. Okay.
Maybe, but in real system, the user still see the MPLS, BGP, and this interface.
Let's talk offline. Okay.
Yeah. So I think maybe this model is very simple and straightforward. But if we want to let industry can really use this interface, we need to provide a real interface for it. So here we learn some experience from SQL. SQL is a very successful interface for the database, a relation database. It's hiding the internal implementation, how to store data, how to search data, any algorithm you don't care about it. You only want to express how to manage the data. It's a very good reference. SQL is why SQL can successful. It's based on relation algorithm, algebra, and the relation model. So today network we can abstract a simple network entity model and a network behavior model. Why can we provide a language based on this simple model? That's all idea. So we build a NEMO language based on just the resource model and the behavior model and the query requirement. So we provide a NEMO network domain-specific language for user to handle the network. Here we provide 3 group primitives. One group is for the resource access, node, connection, and flow. Node can be a function node and can be a logical node. It's depend on what user want. For the capability, the behavior and the query is a capability. So the capability, the second group is a capability, the primitive, query, policy, and the notification. The third group is a model definition. It can extend the exact type of the node and the action. Maybe there is a new firewall node. We can extend the node type to support it. We only have 3 group of primitive and 15 primitives, but user can easily handle network resource and network behavior.
So when you talk about network behavior, what do you mean? Do you mean the forwarding configuration? Or do you extend it to also configuring quality of service queues and other type of primitives that typically are not exposed directly in control?
Yeah. The behavior control is by the policy. Policy can apply to the entity, so you can control the resource. You can get more capacity of the node. For example, a firewall. You can change the firewall capacity from 1 giga to 10 giga. You can change the bandwidth of a connection from 100 meg to the 1 giga. This is the behavior of the resource. The second behavior is for the forwarding, the flow forwarding behavior. Flow forwarding behavior is their path. So it's not the device internal behavior. It's a network level behavior. It's a flow forwarding path behavior. So user only care about the specific flow, goes through which point and goes through which function node. So this is that's all network level behavior. Yeah. So here is a example. This is a typical the enterprise requirement. There's a multi-site enterprise, 3 sites, 2 branch and the headquarters. First, they need to connect them together, and the headquarters need to connect to internet. But for this connection, they want to more flexible. It's a bandwidth on demand. It means in daytime it's use 1 giga bandwidth. In the nighttime only need 100 meg. It is very simple scenario. And for the internet access, they need security some requirement. The email and HTTP to the internet, they hope they can go through the firewall. That's the enterprise the requirement.
Mm-hmm.
But today, they need communication with the service provider many times, and the service provider need translate many configuration, many command line, maybe 100 and 1,000 command line to configure to the device. It's a real situation. But if use the intent programming language, user can by themselves model their requirement. Simple describe node. Node is their office site is node. It's a logical node. The connection is the connection requirement to connect them, and the flow. They for this to internet bandwidth on demand requirement only a policy applied to this connection. Condition is night time. Action is cite the bandwidth to the 100 gig. This is, so all user want the requirement can easily be described by this programming language. So and this is based on the primitive, so user can directly send this script to the SDN controller. SDN controller can automatically map this, understand what customer really want for the resource and for the network behavior, and map the resource to this requirement, and then translate to the real interface to deploy to the real device. So I think this programming language can make network automatic from the self-service to the automatic deployment. Maybe this whole thing's done only need several minutes. So here we give a prototype the architecture for this. It's very first the user input the NEMO language, the script, the language processing module, compile it. Compile it get user intent network. In all system, we provide each tenant have a virtual network space. So each tenant have its own virtual network space. Different tenant have a different virtual network space. They can control their own virtual network space by themselves and didn't care about others. So this is the language processing part. And in the user virtual network space, record the user virtual network resource and forwarding behavior requirement. And from this information, we can translate and use a model mapping module to translate it to the real network. In this model mapping, first allocate a resource from the real network and map it the resource configuration to the real device interface.
Is it designed for the current hardware, or does it require completely new devices?
You mean the device is
The controller say the switches?
I think it's why it's new or it's if this device controlled by the SDN controller, I think it's all can be controlled. All the resources can be controlled by the SDN controller. Sorry.
No, I was just wondering if the current deployed technology can handle it, or if it requires a new generation.
Yes, I know. I think that if in all discuss the customer, if a part of network controlled by the SDN controller, this part network resource all be controlled by the SDN controller. If so, this can easy to management and monitor. So, but the device is maybe an old device.
Is the SDN controller speaking OpenFlow 1.0?
No, that's. I think it's not depend on OpenFlow. It's only just like Collins mentioned, the SDN controller. The original SDN maybe should decouple the control plane and the data plane use OpenFlow, but today most of the SDN controller can control the traditional device use the traditional interface, such as netconf and the PCEP and this thing. But the resource is all be controlled by the controller.
Normalization is a pain.
But maybe if you have the OpenFlow, it can easy, because this model mapping, if only have a OpenFlow, is easy to map to the OpenFlow interface. But if a different the real device interface, the model mapping, it's a little bit difficult. So I just introduce our understanding and our work. Here I quickly introduce our working area. Actually, we work in two areas. One is in the standard, one is in the open source. Because this network programming language is an important interface to the application and the controller. So we think it's if it can be standard, it's very important. So we work in standard in IETF and ONF. In standard, we try to work with industry to standard some model, information model and data model. And based on this information model and the data model, we can standard language to use the network. And on the other side, in the open source, in the Open Daylight, just Colin also mentioned, we already have a project in the Open Daylight, try to work with the industry to build a real intent engine to compile and translate the user network intent to the real network. So here we have two mailing lists for this work. Hope you are interested. You can participate in this area. Also, we have a simple understanding for the network abstraction, and we have designed some language and some prototype, but it is still very early stage work. Here we list some the future works. For example, the conflict resolver. In this specific model, in all network entity model and the policy model, the conflict is object overlap and the condition expression and the action conflict. This thing, and the other has a debugger and simulation. Here I only list some part of the future work. There still have a lot of work problem need to resolve. Finally, I will welcome you again to participate to the intent-related work. Hope you can join the mailing list to discuss this related work. Provide you comments and you questions and your suggestions. Thank you.
I was wondering if you have like VMs readily available that we just download and play with this stuff.
Sorry?
Do you have like any virtual machines or images that we can download and play with?
Yes. Actually, now before we join in the ODL, we use our own controller. We have image to provide the controller and this. But now we join in the ODL. So maybe we in next month we will provide the source code in the ODL. So you can directly download from the ODL.
So the source code is not yet published for this NEMO language?
Yes, we will.
Is it published inside the OpenAI?
Yes.
Okay.
So if SQL has relational algebra, what does NEMO have? You mentioned earlier this comparison with SQL inspiration,
Yes.
taking inspiration from SQL. What semantics does NEMO have? SQL has, you mentioned relational algebra, relational models.
Yes, I think the SQL is reference for us because it's also a declarative language for the database, and it's very human readable the language style. So here we also the node, such as for example, in this example, the user only describe the connection enter node from branch 1 to the headquarters, and with property and bandwidth as like this thing. This is a semantic for us.
So your examples are remarkably similar to the examples we write in Pain. The main difference is that in participatory networking, we actually, you talked about how you have these isolated pieces where different people control different parts. In participatory networking, you have hierarchical flows. So I can basically say, so speaking of what the semantics there would be, so the semantics is actually given in terms of hierarchical flow tables, and hierarchical flow tables have their own semantics. So I can delegate, for example, I can say, you know what, I want you to be able to control this part of the network. So I'm going to give you this part of the network. So you talked about the problems of composition. So that's one of the things that the Pain semantics actually deals with. We give operators that are compositional so that we can do composition and we can avoid these problems after the fact. So there is a formal semantics. It is in terms of these things called hierarchical flow tables. I can say, I'm delegating this to you and delegating that much to him, and each of you can make allocations based on those delegations, and the compositions are going to work out later after the fact. Exactly. So that's the design from scratch. So I think you're going to end up sort of reinventing that wheel, and if you don't think about the semantics up front, you'll end up, having problems with it.
Maybe I don't know. I understanding is it correct for you? You mentioned the composition. I think it's not the NEMO compared to the sub-control domain, the controller. It's an internal implementation. Customer doesn't care it. It's a controller in internal behavior. Maybe multi-domain, maybe one domain. Customer doesn't care. I mentioned the composition is a connection, one connection, two connection, three connection. It's a network. This is a composition.
I think what the Shriram is trying to point out is, for instance, in this example, imagine that your policy 1, ID 1, is in direct conflict with the policy 2. Okay, you're creating a conflict.
Yeah.
And somewhat you're asking two different things to the network. So you need to resolve this type of conflict.
Yeah.
Detect and resolve.
Yeah. I think that is all very important future work. But I think
so. What Shriram is trying to tell you is that there is one paper that appeared in SIGCOMM 2013. It's called Participatory Networking, and that paper will give you a mechanism to detect and resolve conflict.
Yeah.
So you guys probably should check out that paper before reinventing.
Yes, in the academic in the industry already have some discussion about the conflict resolve this thing, but it's still maybe it's a policy composition. It's not conflict resolve in all model. Conflict first is applied the entity. Does it overlap? If it doesn't overlap, it's not conflict. When they overlap and check the action, is it action conflict? Maybe action, no conflict is also okay. So I think the conflict detect is based on the model.
Okay.
And I mentioned the composition is not the conflict composition, or it's a connection and two connection, maybe two connections still, but three connection maybe is a network, it's a VPN or it's a virtual network, it's a new things. So it's this sentence, this language, this sentence is related to the others. It's okay.
Any more?
Thank you very much.
All right, let's thank you.